Hello students, let's see xenon compounds. So first of all, xenon fluorine compounds. Xenon fluorine compounds are prepared by direct combination of xenon and fluorine. So Xc plus F2, that gives XeF2, XeF4 and XeF6. So these xenon fluorine compounds are formed by the direct combination of xenon and fluorine. But the reaction conditions are important. First reaction condition is 1 bar pressure and xenon is present in excess. Second one is 7 bar pressure and xenon fluorine ratio is 1:5. Third condition is 60 to 70 bar pressure and xenon fluorine ratio is 1:20. So the reaction conditions are important. Anyways, xenon fluorine compounds like XeF2, XeF4 and XeF6 are prepared by the direct combination of xenon and fluorine. Now let's see another preparation of XeF6. So XeF6 can be prepared in two ways. The second method is XeF4 plus O2F2. We will get XeF6 and O2. These xenon fluorine compounds are colorless crystalline solids, and they are fluorinating agents. So these are colorless crystalline solids and fluorinating agents, and these compounds are hydrolyzed very easily. For example, XeF2 on hydrolysis gives Xe plus HF plus O2. So this is about the hydrolysis. Then comes chemical properties. First of all, there is fluorine acceptors, not fluorine, it is fluoride acceptors and fluoride donors. So in the first equation, XeF2 plus PF5 gives XeF plus PF6. Second equation, XeF4 plus SbF5 gives XeF3 plus SbF6 minus. So in this case, in these two cases, this PF5 is a fluoride ion acceptor. So this is a fluoride ion acceptor. So that is why it is PF6 minus. Here also SbF5, we will get SbF6 minus. So these two are fluoride acceptors. So F minus acceptors are there, and this xenon fluorine compound reacts with F minus acceptors to form a cationic species. Here we can see the cation XeF plus. Here it is XeF3 plus. So cationic species are formed when the xenon fluorine compounds are reacting with fluoride acceptors. Then xenon fluorine compound, this reacts with a fluoride donor. This is a fluoride donor, MF. Here M can be sodium, potassium, rubidium or cesium. So this is a fluoride donor. Since it reacts with a xenon fluorine compound, it produces a fluoroanion. So fluoroanion is formed in this case, fluoroanion. In the first case, a cationic species is formed, cationic species. So with fluoride acceptors, cationic species is formed. Fluoride donors, fluoroanion is formed. So that is about the chemical properties of xenon fluorine compounds. Now let's see xenon oxygen compounds. They are prepared by the hydrolysis of xenon fluorine compounds. XeF4 plus H2O gives Xe plus O2 plus HF plus XeO3. So xenon oxygen compound. Then comes another preparation, XeF6 plus H2O, that is also hydrolysis. Here XeO3 is formed. So xenon oxygen compounds are prepared by the hydrolysis of xenon fluorine compounds. Then partial hydrolysis. On partial hydrolysis, HCF6 plus H2O produces HCOF4. In the second step, HCOF4 produces HCO2F2. So partial hydrolysis also takes place in this case. On hydrolysis, xenon oxygen compounds are formed. HCO3 can be formed from HCF4 or HCF6. So this is about partial hydrolysis. Now let's see the structure. First of all, the structure is very important. First of all, the structure of HCF2. So, according to VSEPR theory, we will find out the geometry. So, for that, we need to find out the bond pairs and lone pairs. It will be half into Xc is having 8 valence electrons and 2 bonded atoms. So, it will be 5. So, out of 5, 2 will be the bond pair and 3 will be the lone pair. So, we can draw the structure like this. Since total is 5, we are expecting this shape, but the presence of lone pairs makes a different structure, that is fluorine is here and this will be lone pairs. So, HCF2 is having a linear structure. So, HCF2 is having a linear structure. So, this is the structure of HCF2. Now, let us see HCF4. HCF4. Here half into 8 plus 4, that is 6. So, out of 6, 4 bond pairs are there and 2 lone pairs are there. So, it will be Xc. So, 4 bond pairs and 2 lone pairs. So, this will be the structure. So, this is square planar. This is square planar. So, HCOF4 has square planar structure. Now, let us see another compound, that is HCF6. So, HCF6, it is half into 8 plus 6, that is 7. Out of 7, 6 will be bond pair and 1 is the lone pair. So, Xc, we can draw the structure like this. So, F6 and 1 is lone pair. So, we can draw the lone pair like this. So, this can be the structure, and actually this is not a pure octahedral, it will be a distorted octahedral. So, it will be a distorted octahedral structure. Distorted octahedral is the shape of HCF6. Now, let us see the structure of 2 xenon oxygen compounds, that is XCO3. For XCO3, again half into 8 plus 0. So, oxygen is doubly bonded. So, we are considering singly bonded atoms. Since it is doubly bonded, it will be 0. So 8 plus 0, it will be 4, and out of 4, 3 will be bond pair and 1 will be lone pair. So in the case of oxygen, we know it is a double bond. It is connected with a double bond. So 3 bond pairs and 1 lone pair. So this is the structure. So this is pyramidal. This is called a pyramidal structure. So this is XeO3. Now let us draw XeOF4.